Welcome to UGC lecture series in computer science. We are going to see a series of lectures in the subject operating system. This subject is for the students who are doing their 5th semester BSc degree program, and this belongs to paper number 8. So in today's session we are going to see topics from unit number 1. So in unit number 1 we have various topics, out of which we are going to see a topic on the CPU scheduling algorithms and the scheduling criterias. So the scheduling algorithms. What is a scheduling algorithm? In my earlier session, this CPU scheduling algorithm has been, this lecture was divided into 2 different sessions, and session 1 was about the basic concepts, so to know the basic concepts of CPU scheduling and about the CPU burst time and IO burst time. So apart from that, we saw certain topics on the scheduling criteria required for CPU scheduling, and then we saw certain algorithms even. So we have seen 2 different algorithms in our earlier session. One was first come first served algorithm, the other one was shortest job first algorithm. So the first come first served algorithm denotes whatever process comes first will be executed first, and whatever process comes at the last will have to wait in the queue until the first process gets completed its execution. So that was one algorithm which we saw, and then we have seen one other algorithm called the shortest job first algorithm. In the shortest job first algorithm is that it is based on the burst time, how much of time that is required for executing, the time taken for executing a particular process is called as the shortest job. Which process takes the shortest time to complete its execution is taken first, and then the average waiting time is calculated. So based on the CPU scheduling is done based on different algorithms, and this approach, any approach can be taken for any considerations. So the remaining algorithms are about the round robin algorithm and about the priority scheduling algorithm. So in today's lecture we have certain contents such as priority scheduling algorithm, round robin algorithm, and then we will be seeing about the queues as multi-level queues, thread scheduling, p-thread scheduling. P-thread is nothing but POSIX thread scheduling, and window scheduling. Now what is a priority scheduling? What do you mean by a priority scheduling? What do you mean by priority? First of all, in literal terms, in layman terms, if a particular person, if there are certain 5 people in a group, or let us consider an example of a schooling. In your school, you people have been ranked. Based on the marks, students are being ranked. A person who gets first rank is different from a person who gets third rank. So he is being given the first priority. Or in other words, if you are going to take a different example, as if you are going to call the VIPs for a function, very important persons for a function, supposing if the chief minister of a particular state is going to attend the function, and the ministers of the state are also going to attend the function, and the visitors audience are going to attend the function, press media is going to attend the function, in this case to whom will you give the top priority? Definitely the chief minister of a particular state will be assigned the topmost priority. Next comes the minister of the state. The different set of ministers will be given the second set of priority. Then the MLAs of that particular state will be given the third priority. Then the press people will be given the next priority. Then the audience. So this is how we prioritize. So we are assigning a priority. We are assigning certain ranks. So based on the priority, this happens. How do you schedule? So that is what we are going to see in this priority scheduling algorithm. How to assign a priority and then how it executes is what we are going to see in this priority scheduling algorithm. A priority is a number which will be an integer number. Usually it should be an integer number, and the shortest number will be having the maximum priority. Say for example, if I am going to assign a number called 3 and a number called 7, there are 2 processes. Consider and for process P1 I am assigning a number called 3, and for process P2 I am assigning number called 7. So in these two processes, which has the maximum priority? Process 3 has the maximum priority when compared to process 7. Process 1 has the maximum priority when compared to process 2, because process 1 has been assigned a number 3, process 2 has been assigned a number 7. It is the shortest number has the maximum priority. So here in this, it is an integer number and this has a maximum priority. It is given as priority number is associated with each process. The CPU is allocated to the process with the highest priority. Smallest integer has the highest priority. It can be either preemptive or non-preemptive. The preemptive and non-preemptive we have seen in the earlier sessions. I suppose we have seen much about this preemptive and non-preemptive in the previous session. So I hope you might be remembering those concepts, preemptive scheduling and non-preemptive scheduling. So now let us see how it works. So this SJF. So SJF is also a priority scheduling. What do you mean by SJF? SJF is the shortest job first. In the shortest job first, we take the minimum time, we take the process that completes the execution within a minimum time frame. That set of process we call it as a shortest job. So that gets the maximum priority and that is taken at first, and then we move on to the second max. That is, say for example, if process P1 completes in 3 milliseconds time and process P5 completes in 5 milliseconds time and process P2 completes in 7 milliseconds time. So then what we do is we take first process P1 which has completed in 3 millisecond time, then we take process P5 which completes in 5 milliseconds, and then we move on to process P2 which has completed in 7 milliseconds. So here in this case, the shortest time that is taken for a particular process to complete, we are taking it. So we can as well call the shortest job first algorithm as a priority based algorithm. Here in this, in the shortest job first algorithm, the priority scheduling, where priority is the inverse of the predicted next CPU burst time. So what are the problems that are possible with the priority scheduling? There are two types of problem possible. One is called as a starvation problem, other one is called as an aging. So starvation is low priority process may never execute. Solution aging is, as time progresses, increase the priority of the processes. Say for example, if we are going to have say for example we have 10 different processes, out of which the minimum time required for, that is, the out of 10 processes, I gave you an example with respect to 3 milliseconds, 5 milliseconds, 7 milliseconds. Supposing if you have a process which got executed for 5430 milliseconds, the other process got executed in 7000 milliseconds, third process got executed in 9000 milliseconds. So out of which the first process is said to be the shortest job, so it got executed in 5432 milliseconds. So you are going to take that. So but even then, the other process, the process 3, the time taken for the process 3 to get executed is pretty longer when compared to the other process. So because of this, the process 3 may starve for long. So it may be waiting for a very long time in the queue. So that is that is an example that is called as a starving. That is called as process starving or problem starving. Then the next one is to be aging. Aging is nothing but, again over here, the process P3, it has to wait till process P1 to get completed, till process P2 to get completed. So because of this, the process 3 have to wait for a very long time frame, and because of that, process 3 gets aged out. It has to, because it is waiting for a pretty longer time, so it has got aged out. So that these are the two problems that may occur because of this. These are two problems that may occur in this priority scheduling. So let us see an example, a practical example with respect to a priority scheduling. Here are the different sets of processes. Let us consider there are 5 different processes from P1 to P5. So P1 takes a burst time of 10 milliseconds to complete. P2 takes a burst time of 1 millisecond. P3 takes a burst time of 2 milliseconds. P4 takes a burst time of 1 millisecond. P5 takes a burst time of 5 milliseconds. Now we are going to see an algorithm called as priority scheduling algorithm. We are not going to see a shortest job first algorithm. We have already seen that algorithm. So in this priority scheduling algorithm, some priority has been assigned for each and every process to get completed. So say for example, if particular process, if a printout has to be taken place, you have an office setup wherein you are working, your manager is working, your director is working. So you are giving a printing request. You have only one printer available in your office. So at that time, at a single instance of time, if three different people are going to give a printing request, it is one is you, other one is the manager, your manager, other one is the director. Whom do you think it will be executing at first? Say for example, you have given some 2 seconds earlier than the manager, and this manager has given a printing request some 1.5 seconds ahead of you. Then the director gives some 1 second later than you. So whom do you think it will be printing first? It will always print for the director, because for him it has been prioritized in such a way that he has been given the top priority, because it may be his own company, it may be a proprietorship firm. So he has been given the maximum priority. So for him it will be printing first, and then it will be printing for the manager. Then the poor guy, the last man is you, so it will be printing for you. So this is how it has been scheduled. So it is different from a shortest job first algorithm even. Now let us see an example how it has been prioritized. So P2 has been given, process P2 has been given priority number 1. Process P5 has been given priority number 2. Process P1 has been given priority number 3. Process P3 is given priority number 4. Process P4 is given priority number 5. So out of which, let us create a Gantt chart. So based on priority number 1, P2. So the waiting time of P2 is 0. So it takes 1 burst time to complete. Then P5. Waiting time of P5 is 1 and it takes 5 burst time to get completed, 5 milliseconds. So 1 plus 5 becomes 6. Then priority number 3. Waiting time of P1 is 6 milliseconds. 6 plus 10 becomes 16. Then priority number 4. Waiting time of P3 becomes 16 milliseconds. 16 plus 2 milliseconds it takes to complete. So 16 plus 2 is 18. Then the last one is the P4 process. It takes 1 millisecond to complete. So waiting time of P4 is only 18 milliseconds. So it takes 1 millisecond to complete. But if you have been putting it the other way, P4 takes only 1 millisecond to complete, but it has to wait for 18 milliseconds in order to get executed. When you take up an average waiting time out of it, you can calculate it as the 6 is said to be the waiting time for process P1. 6 plus 0 plus 16 plus 18 plus 1 divided by 5. 5 because you have 5 different processes. So when you calculate, you get it as 8.2 milliseconds. So this is an example for a priority scheduling. Now we will be seeing the next algorithm called as a round robin algorithm. What is a round robin algorithm? So for executing a round robin algorithm, it requires a quantum time frame. Quantum timers, each and every CPU, the CPU will be allocating a maximum resource for one particular process. Say for example, if it is going to give you a time slice of 4 milliseconds to get executed, you have let us consider there are 4 different processes, out of which process P2 and P3 gets executed, its completion gets executed within 1 milliseconds. Wherein this process P1, it takes somewhere around 20 milliseconds to execute its process. But what is the maximum time frame that has been allocated by this CPU? It has allocated only 4 milliseconds. So what happens here is, this process P1, if it has 20 milliseconds, it gets segregated into 4 milliseconds, it gets segregated into 5 different processes. It gets splitted into 5 different processes. So the first part of the 4 milliseconds gets executed first. Then 1 millisecond gets executed for the process P2. Then 1 millisecond gets executed for process P3. Then 2 milliseconds of this segregated process gets executed. Then it continues. So likewise, the execution takes place in a round robin algorithm. So round robin algorithm works fine with a time quantum. So each process gets a small unit of CPU time, a time quantum considered as Q, usually 10 to 100 milliseconds. After this time has elapsed, the process is preempted and added to the end of the ready queue. Let us see this example with a real-time problem. Here the timer interrupts every quantum to schedule next process. So an example is, let us consider this example, an example of round robin with time quantum equal to 4. That is, the CPU has allocated only 4 milliseconds, wherein you have 3 different processes, P1, P2 and P3. The time taken for the process P1 to complete is 24 milliseconds. Time taken for P2 to complete is 3 milliseconds. Time taken for P3 to complete is 3 milliseconds. So the Gantt chart is drawn likewise. So for P1 it takes from 0 to 4. Because why 4? Because it needs 24 milliseconds to complete this burst time. But only 4 milliseconds has been allocated by the CPU for its execution purpose. So what happens here? Here it takes 0 to 4 milliseconds has been occupied by this P1 itself. So P1 has been segregated, or P1 has been left out with 20 milliseconds of the burst time. So this 20 milliseconds has to get executed. But in the queue, in the pipeline, you have the P2 and P3 for execution. So this P2, what happens? It comes at the next. So here, after this 4 milliseconds has taken place, P2 executes for the remaining 3 milliseconds. So it comes to 7 milliseconds. Then P3 comes into picture. Again 4 milliseconds has been allocated by this quantum time quantum. So even this P3 takes only 3 milliseconds. So P3 executes. So 4 plus 3 is 7. 7 plus 3 is 10. So these processes got executed, but it is not a completed state, wherein P1 for 24 milliseconds of its burst time, only 4 milliseconds got executed. Remaining, it has been left out with 20 different milliseconds, and all the 20 different milliseconds cannot get executed at a single state because the CPU has time slice of only 4 milliseconds. So this 20 milliseconds will be divided into 5 different halves. 5 different halves in the sense, for each and every 4 milliseconds there will be a split. So you require 4 into 5 or 20 burst time is required. You have only 4 milliseconds time slice available. So 20 divided by 4 equal to, you get 5. So you require 5 time quantum in order to complete this process execution, in order to complete the P1 to get executed. So let us see in the Gantt chart. After this P3 of 10, we have this P1. This P1 takes from 10 to 14 over here because 4 quantum has been left out, and again it takes the next 4 from 14 to 18. Again it takes the next 4 from 18 to 22. Again it takes the next 4 from 22 to 26. Again it takes the next 4 from 26 to 30. So what is the waiting time over here for this P1 to complete? It has taken 26 or the 30 seconds to complete the full execution. So here for this P1, all this round robin works only with respect to a time quantum, only with respect to a time slice. So this Gantt chart shows the example of a round robin algorithm. Then this example is how does it work with an SJF has been given here. Typically higher average turnaround time than SJF is the order of the day for this round robin, but it gives a better response. So this Q is nothing but the time quantum. It should be large compared to the context switch time. Q will be usually from 10 milliseconds to 100 milliseconds, whereas context switch, which we have seen in the earlier lectures about the context switch, about a process context switch, so it will be less than 100 microseconds. So wherein this scheduling we speak in terms of millisecond, wherein in terms of the context switch, process context switch, it will be spoken in terms of microseconds, 100 microseconds. So it is less than 100 microseconds. So that is about the round robin algorithm. We will move on to the next topic, that is called as the multi-level queues. What is a multi-level queue? A multi-level queue is a queue is wherein we align the processes one behind other. Multi-level queue is two or more number of queues are being formed or framed in such a way that the process are being assigned one behind the other. So we have two different sessions in this. One is called the foreground process, other one is called as a background process. The foreground queue is an interactive queue. Background queue is a batch queue. What do you mean by an interactive queue? What do you mean by a batch queue? An interactive queue is one wherein you can interact with the system. Again, in one of my earlier lectures, I gave you an example with respect to an ATM counter, wherein you go to an ATM counter, you try to withdraw some money. Say for example, you want to withdraw somewhere around 10,000 rupees. So you just put in your card and you type in your key pin number, and then it will be going to a menu, and in that menu you will be having different menu items. When you select a withdrawal item, you will be prompted to a withdrawal screen, in which if you are going to type in as 10,000, it will be checking in the server whether you have 10,000 or not. If you have the 10,000, you will be getting the money. So you give in an input in the foreground, in the screen, on the screen, you type 10,000, you get the value, you get the money from the ATM machine. Supposing if there is no funds available, it will say there are no funds available. Even that will be put in your foreground screen itself, in your front screen itself. So that is one aspect of a multi-level queue, wherein at times even in your ATM you may have to wait for the process to get completed. Say for example, someone has created a rumor stating that one particular bank has gone into a loss and they are going to close the accounts, and they are going to close the bank by midnight, by 11 o'clock, today by midnight 11 o'clock. So what happens immediately? Whomsoever has an account in that bank and whomsoever has deposited a very large amount of, say for example, somewhere around 5 to 10 lakhs amount, they will be very much eager to take the amount at the earliest. So at the same instance of time, two or more number of persons, if they are going to access the same server that is available in the bank, then we will be getting a delay. We will be put under a queue. So even in the foreground, if you type, I want to withdraw 10,000 rupees, till the money comes out, it may be, you may be having a presumption that you are going to use, you are the only person using the server, but there may be hundreds of users who will be, millions of users who will be using the server. So at the same instance of time, if they are going to click, then it will be getting into a delay. So that is called as a multi-level queue delay, which has been taking place in the foreground. Next is the background system. The background queue is nothing but a batch system. What is a batch? Again, in one of my earlier lectures, I gave you an example of a batch system. What is a batch system? Is you schedule a time frame for its execution. For example, if a result is going to be declared by midnight 12 o'clock, it does not mean that the controller of examination of that particular university sits in front of the system by midnight 12 o'clock, and if he is going to press the enter key. He will be leaving the office very early by morning 11 o'clock itself. He will be scheduling a particular time, that only in this particular time, this particular result has to get executed. That is called as batch execution. Only in this particular time you can pay later. You have an option of when you're going for a fund transfer, pay now or pay later. When you click pay later, it will ask for date and time. So this particular date and time, it can be paid. So that kind of scheduling. I gave you one other example in my earlier sessions as the printing, the passbook print or the printing that takes place in the bank after the working hours. Whatever the day-to-day transaction that has been carried out has been put as a task and it has been printed out. Such an operation, you call it as a batch job. So there may be, let us consider the same old bank example wherein 10 different employees are working. They would have worked on during the working hours, and after the working hours, the printer, it will be keep on printing whatever transactions that these 10 different employees has made on that particular day. So that is called as a batch job. So for all these 10, in order to serve all these 10 different employees, it cannot serve at a stretch. So these people have to wait in the queue and it will be served only one by one. So such a type of queue delay that takes place at the background is called as a background multi-level queue delay. Then the next is about the process permanently is given in the queue. Each queue has its own scheduling algorithm. If it is of a foreground delay multi-level queue, we go in for a concept of round robin algorithm. If it is of a background multi-level queuing, we go in for a concept of FCFS. FCFS is first come first served algorithm. So we have seen about this multi-level queuing, about the ready queue types as the foreground queue and the background queue. So now let us summarize this session, whatever we have seen in this session. So we have seen topics on, we have learnt about the priority scheduling algorithm, and we have as well studied about the round robin algorithm and the quantum time that is required for the usage of this round robin algorithm. We have seen certain details on this multi-level queuing algorithm. We have as well seen the two types of ready multi-level queues. The two types were, one was the foreground multi-level queue, the other was the background multi-level queue. Let us now see the possible questions, the questions that are possible for this session. So question number 1, what is priority scheduling? Question number 2, how round robin approach works? Question number 3, what is a quantum time? Question number 4, what is a multi-level queue? Question number 5, mention the different ready multi-level queues. So with this, we come to the end of the session. So we will see forthcoming topics on operating system in our next session. Thank you.